Hello, in this video we will talk about comparing tests. Hello, in this video we will talk about comparing treatments with a control in ANOVA using Dunnett's test. So similar as in previous video, when we think about the comparisons between treatments groups after ANOVA, so we will be faced with the significance level for composite tests because we do multiple tests, so we cannot set a significance level for one of the multiple tests. So if we set, for example, 0.05 for individual comparison, if then after we do multiple tests between groups and groups, then we will get a much higher error rate for type 1 error. So to face with this situation, there are several ways. One is two-case test and one is Dunnett's test. But this video is talking about a different situation because we do not want to do all possible pairwise comparisons. We just want to do several parts of the tests. So which means we want to test the comparisons between several treatments means against one control mean. So for example, if we have 4 groups, we can set one group is a control group. Then we just do the tests from the other 3 groups against this control group. So if we want to do this kind of tests comparisons, and we want to set a joint significance level alpha, so which means for all tests, we set the type 1 error is 0.05. So which means for the individual tests will be much higher, much lower significance level, or say we will not so easy to make a rejection for each individual comparisons. Hence, we will get a 0.05 for the joint significance level. So we can use so-called Dunnett tests to do such kind of treatment groups against a control group comparison. So for the Dunnett tests, its idea is we set H0, or the null hypothesis is mu0 equals mu I for the treatment groups from 1 to k, and H1 alternative hypothesis is their comparison is not equal from mu0 control group to mu I, and I is for the 1 to k. And the test method from the Dunnett test is very easy because we just calculate odd mean value for each treatment group against the mean value from the control group. Then we take a square root of the 2 times s squared. This is sample variance from all the samples from all the groups, and this n for all the sample observations. So we calculate each di, then compare di against its rejection value. So if di larger than this value, then this comparison will be significant. So which means this treatment group is not equal to the control group. And this number can be found from Dunnett's test table. So for example, alpha 0.05, so Dunnett is for degrees of freedom 12, we can get this value. and this K for the treatment group, how many groups, but excluding the control group. So next we take a look at an example. The control group here and 3 test groups and their corresponding mean value for the group. And question is, we want to test if they are significant for each group comparison. Then we calculate the S-square sample variance. If we look at there are 4 group, total 4 group, and there are 5 samples. So degrees of freedom 16 here, and for choose S-square divided by n is 5 here. So we can get this value is 0.95. Then calculate D1, D2, D3, which are difference between each treatment group mean against the control mean, then divided by its corresponding. This is the same for each group comparison. Then we can get D1, D2, and D3. And D3 is negative, but the comparison is for the absolute value. So we can see if we compare with the number from the Dunnett table, then we can see only the mean yield for second group is significantly different from the mean yield from the control, right? Thanks for watching.